Okay, what makes this a system is I am going to have more than one equation. This is a quadratic equation. This is a linear equation. And when you're solving a system, you are looking for the intersection point where these two, in this case curve and line, cross. Now, do we remember that if we graph a quadratic, it makes a parabola? If I had a parabola like that and a line like that, would I have any intersection points? So that would be no solution. If I had a parabola like this and a line like that, how many solutions? And these solutions are points. So it's going to have an x value and a y value. And this one over here is going to have an x value and a y value. So there's actually going to be 4 numbers for the answer, 2 x values and 2 y values. Occasionally, you have a system like this. How many intersection points are there? Just 1. But it is a point, so the point is going to have an x value and a y value. So after we solve for the x value, we're also going to solve for the y values. Okay, so how do we do that? Well, these are written, this one is written in standard form, this one is written in y equals mx plus b form. Do you see that the first equation is equal to y and the second equation is equal to y? If they're both equal to y, then that means they have to be equal to each other, because they're equal to y, so they have to be equal to each other. And so that's called the transitive property by the name. By the way, it even has a name. So this is equal to that because they're both equal to y. They're equal to the same thing, so they have to be equal to each other. Now it's a quadratic equation. Do you know how to solve a quadratic equation by factoring? If I'm going to solve it by factoring, I have to zero out one side or the other. You multiply the first number times the last number and write down the factors of 4. If this is negative, then something has to be negative. If this is negative, the bigger number has to be negative. Is there a pair that can add up to -3? If this is 1, then I can use my shortcut factoring. And my zero product rule says the first factor is equal to 0 and the second factor is equal to 0. Subtract 1 from both sides. Add 4 to both sides. And I have my 2 x values. But these are intersection points that I am finding, so I also have to figure out the y value. I go back to one of my original equations. Obviously, I want to use the easiest of the original equations. So this is the easiest of the 2 equations. So I am going to do y equals 2x minus 2. Y equals 2x minus 2. And in place of the x, I'm going to substitute the x's that I found. Do you understand why I'm doing this twice? once for this x and once for that x. And so then that's going to be negative 4. That's going to be 8 minus 2. So my first intersection point, and this is my next intersection point. Now, just to make it easier to type into Schoology, I did not require you to type it in point form. In Schoology, this is what you will see. And so put your smallest x in first and the y that goes with it, and your biggest x and the y that goes with it. These are actually intersection points, and mathematically that's the better way to write it. But I just put it into Schoology that way to make it easier to type. Because a lot of times when we're typing the parentheses and the commas and the negative signs, it's hard to get it all in there just exactly right. So the answers are intersection points, but you're going to type them in this way right here. So example number 2. Y equals negative 2, x plus 2 squared plus 3. That's a quadratic in vertex form. Y equals x squared plus 4x plus 4. That one is in standard form. So if they're equal to y, this is equal to y, and this is equal to y, then they have to be equal to each other. Now, in order to solve that, I'm going to have to multiply this out and then distribute and then add like terms. It's got several steps here. And so you would multiply that together with a box problem. If you multiplied it together with a box problem, that is what you would get. Then this has to distribute. Two times 4 plus 3. And if you combine these like terms, that's going to make a negative 5. I'm going to kind of take a shortcut here to save a step there. Now it is a quadratic. In order to solve a quadratic, I need it to be equal to 0. So I'm going to add 2x to both sides, add 8x to both sides, and add 5 to both sides of the equation. Add 2x to both sides, add 8x to both sides, and add 5 to both sides. So that all of this side will zero out. 1 plus 2 is 3. 4 plus 8 is 12. 4 plus 5 is 9. Now, before I jump in and start factoring, what are you supposed to look for before you start factoring? Is there a GCF? What is the GCF? Is it going to make it easier to factor if I divide by that GCF? The only factors of 3 are 3 and 1. Everything has to be positive here because everything's positive there. X equals -3, x equals -1. I have 2 solutions. I go back to my original equation. I'm trying to decide which one I think is easier. I think the other one is easier. Y equals -2, x plus 2 squared plus 3. Y equals -2, x plus 2 squared plus 3. Now, the reason I think this one is going to be easier is, what is that equal to? -1 squared is +1. And what is that equal to? That's 1, and 1 squared is 1. And so both of these y values are going to be 1. So my first intersection point is going to be -3, 1, and my second intersection point is going to be -1, 1. Which is telling me, just guessing because I hadn't looked at the graph, what I think is happening here. What is that? Do you remember what a negative sign tells you about the graph? It is pointing down. So I think I have one parabola pointing down and one parabola pointing up, and my intersection points are lining up. That's why they have the same y values. I think that's probably what happened. We will be looking at graphing a little bit more next week. So, next example. Now, almost always when they write systems, they give it to you like this, where one is stacked right on top of the other. But to actually solve out a system, a lot of times it's easier if they are not stacked one on top of the other. So when I am writing down this system, I'm writing them down side by side instead of one on top of the other. Sometimes that makes it easier to figure out. So I need them both to be equal to y so that I can put them equal to each other. Is this one equal to y? So the first thing I'm going to do is add x to both sides. Now are they both equal to y? This is equal to y, and this is equal to y. If they're both equal to y, then they have to be equal to each other. Since this is squared, it's a quadratic, so I need it equal to 0 so I can solve it. X squared minus 5x plus 6. When you multiply the first number times the last number, you get 6. 6 has a factor of 1 and 6, and 2 and 3. And depending on what the signs are, either one of those could add up to 5. So when you have a 6 and a 5, you have to be really careful with the signs. If this is negative, the bigger one has to be negative. If this is positive, they have to be the same. So which pair is going to add up to a negative 5? If this is a 1, I can use my shortcut factoring. Now, double check. Does negative 2 times negative 3 equal positive 6? If I add those together, does it equal negative 5? Got my signs correct. Add 2 to both sides, add 3 to both sides, and I have 2 answers. And then I take my 2 answers and plug it into the easiest of the 2 equations. Plug in a negative 2, plug in a positive, what I wrote, not what I said, a positive 2 and a positive 3. So here are my 2 y values. The first intersection point was this much, this x and this y. The second intersection point was this x and this y. When you are solving a system, you are looking for the intersection point. Example number 4. Now, if I solve for y, I'm going to have some fractions. I don't like fractions. There is a smarter way on this one. So, on this first one, the x squared plus 2 is equal to 2y. And the negative x squared minus 4x plus 2 is equal to 2y. This is equal to 2y, and this is equal to 2y. It's equal to the same thing. Because those are the same thing, this has to be equal to each other. These are equal to each other, so these have to be equal to each other. And then I need to solve it. Now, I need to zero out one of the sides. If I zero out this side, I'm going to have a negative x squared. I want to zero out this side so that the x squared will be positive. So I'm going to add x squared to both sides. I'm going to add 4x to both sides. And I'm going to subtract 2 from both sides. I'm going to zero out this side because this had a negative x squared. And so if I zero it out, Over here, I'm going to have 1x plus another x. And that number right there is going to be a positive number. I have a 4x, and what happens to my 2's? Cancel out. 2x squared plus 4x equals 0. That's not a trinomial. And it's not a perfect square. It's not a difference of two squares. The only way you can factor a binomial that's not a perfect square is GCF. Does it have a GCF? Not 2, but 2x. So this GCF is going to need to come out in front. And so the 2's will cancel and x will cancel. 4 divided by 2 is 2. X's will cancel. You with me so far? So the first factor equals 0, or the second factor equals 0. Divide by 2 and x equals 0, or x equals negative 2. Go back to my first equation, looks easiest. And in place of the x, squared plus 2, 2y equals squared plus 2. What is 0 squared? 0 plus 2. Divide by 2. This is going to be negative 2 squared would be 4 plus 2. Divide by 2. And y would be equal to 3. And so your two intersection points are going to be 0 and 1, and negative 2 and 3. And so these are your solutions.